This is section 2.3, and this will be video 1 in this section. We're going to start talking about polynomial functions and their graphs. Now, today we're really going to be focusing on what is a polynomial and its characteristics, and then talking about the end behavior of polynomials. So, in order to identify a polynomial, they're written in this form that's shown in blue. Now, this can be kind of tricky, so I'll just show you an example of what a polynomial could look like. The a sub n's are just coefficients. So this just means a coefficient, another one, and so on. So example, 5x. And then to the n just means to an exponent like 4. Minus 3x, for example, squared. Plus 2x plus 1. This is an example of a polynomial. Now, one thing that we have to know is that the a sub n's have to be real numbers. So your coefficients can't be imaginary numbers. And your n's are your exponents, have to be positive whole numbers. Or positive integers in order to be a polynomial. So you can't have fractional exponents or negative exponents. That will make it not a polynomial. The other thing I want to make sure you know is that the degree of the polynomial, when we talk about degree, the degree of the polynomial is just what is the highest exponent. So for example, in the polynomial I gave you, the degree here would be 4 because the highest exponent is a 4. So that's what a polynomial looks like in terms of its equation. Now, in terms of its graph, in order to be a polynomial, the graph has to be smooth and continuous. So you can see, looking at a few of these graphs here, that this first one, it continues on and on forever, and it has nice smooth curves. Since it's smooth and continuous, it's a polynomial. Same thing here with the next one. Smooth and continuous. It goes on forever, and it has nice smooth curves. Now, the next graph is smooth, but look at, there's a jump in the graph. Since there's a jump right there in this graph, this is not a polynomial. And the last one, it's continuous, but it has these sharp curves. Since it has sharp curves, it is not a polynomial. So these two over here, not polynomials. The other two are. So the graph of a polynomial, just remember, it has to be smooth and continuous. Now, we're going to determine the end behavior of the graph. Now, by end behavior, I mean what's going to happen on the far left of the graph and what's going to happen on the far right of the graph, because we have some options. If it's smooth and continuous, our graph might end going both sides down. Our graph might end with both sides up. Again, we're talking about the end behavior, what's happening at the ends out here. One could be falling and the other could be rising, or it could be the other way around. So what we're going to look at with this leading coefficient test is which of these cases do we have given a certain polynomial. To do that, we're going to look at the leading coefficient. Now, leading coefficient just means it's the coefficient in front of the biggest degree. So the number in front of the highest exponent. Okay? So, we have some options here. The first thing is that the exponent, case 1, could be odd. The exponent could be odd, and the a sub n, the leading coefficient, could be positive. If that's the case, the graph is going to fall on the left side, so it's going to go down on the left side, and it's going to rise on the right side. So it might be something like this. It's going to fall on the left and rise on the right. I like to think of a positive x cubed graph as an example here. So this is x cubed, y equals x cubed, because this is a perfect example of a graph that falls left and rises right. You can see the degree here is odd and the leading coefficient is positive. Now what happens if that leading coefficient instead is negative? If that's the case, we're going to get the opposite. It's going to rise on the left and fall on the right. So now this is like negative x cubed. And that would look the other way. How about now if our degrees are even? Now we can have even positive. That's an example of x squared. Now we can see that the end behavior in that case is that they both rise. Or we could have an even degree with a negative exponent. That would be like a negative x squared. In that case, they both fall. Now that we know what is all these different cases we can have, if I give you an equation, you can tell me what the ends of the graph look like. Now again, right now we're just focusing on the ends of the graph. In further videos, we'll start to talk about what's going on in between. But if I look at these two equations and I want to determine the end behavior, remember we have to do two things. The first thing we have to do is look at the leading coefficient here. Now, in this case, in the first one, our leading coefficient is a 1, and the degree is 3. So we have an odd degree with a positive leading coefficient. That means this is going to fall on the left and rise on the right. That's going to be this case. The first case, case 1. And for our other example, the leading coefficient, negative 49. The degree is 2. So now we have an even degree with a negative, so we know that this is going to fall left and fall right. So really in this case, we know that the graph is going to end going down. What we don't know is what's happening in the middle, and that's what we're going to start talking about in our next videos. Right now, I'd like you to try this question and bring your answer to class tomorrow, and this is the end of our video for today.